the superhero Daredevil. Daredevil was nice enough to leave us this book. In this book, the physics behind this marvelous superhero himself are explained. Thank you.
Speed and velocity. The position of an object in motion changes with time. The speed of an object is the distance that the object travels in a unit of time. Speed is a scalar quantity. The average speed, or v, of an object is given by this formula. Velocity equals displacement divided by time. Acceleration. The time rate of change of velocity is acceleration. A vector quantity represented by the formula A equals change in velocity over time.
And I'm here to talk about gravity. Gravity is the force between the mass of the Earth and the mass of any object in the vicinity of the Earth. The constant gravity of Earth is 9.81 meters per second squared. The ideal falling motion of an object acted upon only by the force of gravity is called free fall. In this book, we were fortunate enough to learn from the grandfather of physics himself, Isaac Newton. Newton left his legacy when he created the three laws of motion. Newton's first law states, an object maintains a state of equilibrium, remaining at rest or moving with constant velocity unless acted upon by an unbalanced force. An unbalanced force is a non-zero net force acting on an object. According to the first law, an unbalanced force always produces a change in an object's velocity, which is a vector quantity. Thanks. Newton's second law states, when an unbalanced force acts on an object, the object is accelerated in the same direction as the force. The acceleration is directly proportional to the magnitude of the unbalanced force and inversely proportional to the mass of the object, as shown in this formula. Newton's third law of motion states, when one object exerts a force on the second object exerts a force on the first that is equal in magnitude and opposite in direction to the other object. Universal law of gravitation. Everybody in the universe exerts a force of attraction on every other body. According to Newton's universal law of gravity, any two bodies attract each other with a force that is directly proportional to the product of their masses and inversely proportional to the square of the distance between their centers. This attractive force that one object exerts on another object due to their masses is called gravitational force. Gravity can be solved by using the equation G, which is equivalent to 6.67 times 10 to the negative 11 newtons times meters squared over kilograms squared, which is also multiplied by mass 1, mass 2, each measured in kilograms, and that total is divided by the radius squared, which is also recorded in
vertical components. The motion of an object traveling in a two-dimensional plane can be described by separating its motion into the horizontal x and vertical y components of its displacement, velocity, and acceleration. A component parallel to the horizon is a horizontal component, and a component at right angles to the horizon is a vertical motion.
Is when a projectile is launched into the air at a specific angle. The angle made is between the horizontal and vertical components. The projectile travels certain horizontal distance known as the range. The projectile reaches a maximum height known as the apex. When the object falls, it is due to the force of gravity. The acceleration for the horizontal component will always be zero. The object will fall back to the surface when there is no more acceleration.
Friction. The force that opposes the relative motion of two objects in contact is called friction. A vector quantity, friction, is always parallel to two surfaces in contact and acts in the direction that opposes the slipping motion. The force of friction is directly proportional to the magnitude of the normal force. The normal force is the force pressing the two contacting surfaces together. On a horizontal surface, the normal force is equally in magnitude and opposite in direction to the v. The constant mu is the coefficient of friction, which is the ratio of frictional force to the normal force and thus has no unit. Static and kinetic friction. There are several kinds of friction. Static friction is the force that opposes the start of motion, whereas kinetic friction is the friction between objects in contact when they are in motion. Once motion starts, kinetic friction decreases. The force of kinetic friction for two surfaces in contact is less than the force of static friction for the same two surfaces. So, the coefficient of kinetic friction is less than the coefficient of static.
An object projected horizontally from some height above Earth's surface obeys Newton's law of motion. If air resistance is neglected, the horizontal component of the velocity of the object remains constant. The initial vertical velocity of the object is zero, but the vertical velocity increases as the object accelerates downward due to gravity. Whether an object is dropped from rest or projected horizontally, the vertical distance followed by the object is the same at any particular instant of time.
Uniform circular motion. According to Newton's first law of motion, an unbalanced force acting on the object always produces a change in the object's velocity. If the force has a component in the direction of the object's motion, the magnitude of the velocity changes. However, if the force is applied perpendicular to the direction of motion, only the direction of the velocity changes. Its magnitude remains the same. In both instances, the object accelerates because velocity changes with time. If the applied force has a constant magnitude and always acts perpendicular to the direction of the object's velocity, the object moves in a circular path at constant speed, experiencing uniform circular motion. Centripetal acceleration. An object moving uniformly in a circular path always has centripetal acceleration, which is an acceleration directed toward the center of the circle. Center-seeking centripetal acceleration is a vector quantity whose magnitude is directly proportional to the square of the speed of the object and inversely proportional to the radius of the circular path in which it travels. Centripetal acceleration is represented by the formula AC equals v squared over r. AC standing for acceleration, centripetal acceleration, and v squared standing for velocity squared over the radius.
Bullseye here, talking about centripetal force. The force needed to keep an object moving in a circular path is called centripetal force. Centripetal force is a force directed toward the center of curvature. Centripetal force, a vector quantity, produces centripetal acceleration. Newton's second law, F equals ma, can be rewritten for the special case of circular motion as Fc equals mac, meaning the force of centripetal force is equivalent to the mass times the centripetal acceleration. Substituting in this expression for centripetal acceleration yields this formula, which is equivalent to centripetal force equals mass times velocity squared divided by r, which is equivalent to the radius.
Coming up there, Bullseye.
Oh, really? You think you're going somewhere, Daredevil? You're staying there, man. You can't overcome friction.
He's right. I gotta overcome my FF, or my force friction, because my coefficient right now is 0.86 since I'm standing on concrete with my rubber bottles. I'm gonna get you, Bullseye.
Oh, yeah? Too bad, because I'm about to accelerate so fast, you're not even going to get a chance to catch me. Come on.
Damn, you just accelerating too fast for me.
Oh, really? Daredevil, you looking for me?
Yeah, I'm looking for you, Bunk.
What are you going to do? You going to jump down from there?
Hell yeah.
Oh, yeah? Well, how fast do you think you're going to accelerate?
9.81 meters per second squared.
Oh. That's it, Daredevil.
Nah, you got it.
Come save me, Daredevil!
Let her go, Bullseye.
Oh, you think I'm going to let her go? No chance. I'm going to release her at an angle of 62 degrees. I'm going to predict that her range is going to be 2 meters and her Y-max is going to be 5 meters. Can you solve for the rest, Daredevil?
How about I just catch her?
How about you just catch her? Die. You ready to run the circle, Daredevil?
Alright.
You think you're going to chase me?
Yeah.
Alright. Well, we're 5 meters away from the force of attraction on birds. You ready to run the circle, Daredevil?
Yeah.
You think you're going to be able to catch me?
Yeah.
Just remember, we're 5 meters away from the center of attraction, and we're about 5 meters away from the radio. Again. You ready to run the circle, Daredevil? Yeah. Just remember, we're 5 meters away from the center of attraction. Our velocity is going to keep changing, but our speed is going to remain the same. You think you're going to catch me? All right, chase me. Catch me now. No! Daredevil, no! I'm waiting.
I got you, Bullseye.
Wow! Daredevil, you're not taking me to prison.
Oh, yeah.
Yes, I am.
Oh yeah? You're gonna have to start moving me.
Oh man, that means I'm gonna need a coefficient of.
I wonder if Daredevil's gonna try and catch me today. I don't know.
I got you, Bullseye.
Ah, rats. Don't take me to jail, Daredevil.
Oh yes, we are going to jail.
Oh yeah, but you're gonna have to start moving me.
Oh man, I gotta open up my static friction with the coefficient of 0.9 due to rubber on concrete. Alright.
Oh yeah? Well, what's your kinetic coefficient gonna be?
My kinetic coefficient is gonna be 0.68.
Oh yeah? Really? Yeah, I'm not going to jail.
Oh, you are, sir. That's your
Oh, really? Fine. Keep taking me there. See if I can.
Wow, this book that Daredevil left us is pretty awesome. It taught us a lot about physics. Oh my god, it's Daredevil!
This book is awesome. What can I say? I'm pretty amazing myself.